Hey everyone, welcome back to my channel. In this video, we're going to solve the zigzag problem using a computational thinking approach. Alright, let's dive into the first step of our computational thinking approach, problem analysis. Here, we'll look closely at what we're trying to achieve and the details of the setup. We have a fixed 10 by 10 grid, which is our robot's world. The robot will start at the bottom left corner of this grid, at Avenue 1, Street 1, and it'll be facing east. Our goal is to program the robot to visit every single cell in this grid by moving in a zigzag pattern. The zigzag pattern means the robot will move across a column to the end turn, and then move back across the next column in the opposite direction. This back and forth motion continues down each column, covering the entire grid. Once the robot reaches the last cell in the Street 1, which is Avenue 10, Street 1, it will finish the task facing south. With these requirements clear, we're now ready to move into the decomposition phase, where we'll break down the problem into specific steps and functions that will help our robot achieve this zigzag path across the grid. To make the robot move back and forth in a zigzag pattern across a 10 by 10 grid, let's break down the task of completing a single zigzag movement into 4 simple steps: moving up, changing avenues at the top, moving down, and changing avenues at the bottom. Moving up guides the robot from Street 1 to Street 10 along a single avenue, taking 9 steps, each moving at 1 street higher. Once at Street 10, the robot must change avenues to continue the zigzag pattern. This involves turning right to face the adjacent avenue, taking a single step forward to move 1 avenue over, and then turning right again to face downward, ready for the descent. Since the robot can't turn right directly, we need to turn the robot to the left 3 times to simulate a right turn whenever needed. Moving down reverses the upward movement, taking the robot from Street 10 back down to Street 1 on the new avenue. Here, the robot again needs to take 9 consecutive steps, each moving at 1 street lower until it reaches the bottom. Finally, at the bottom, the robot changes avenues by turning left, moving forward to the next avenue, and turning left again to face upward, ready to repeat the zigzag pattern. This breakdown clarifies each part of the task, making it easy to implement. With these requirements clear, we're now ready to move into the pattern recognition phase, where we'll identify repeating movements and turning patterns that will help us create an efficient zigzag path for our robot. To recognize the pattern in the robot's movement during the zigzag trip, we can break it down as follows. 5. Moving up, the robot moves from Street 1 to Street 10 along a specific avenue by taking 9 steps in total, repeated 5 times. 5. Moving down, after reaching the top Street 10, the robot moves back down to Street 1 on the new avenue, also taking 9 steps, repeated 5 times. Since moving up and moving down are essentially the same, differing only in the robot's direction, we can combine them into one step called Move Along Avenue. Move Along Avenue, move the robot either upward from Street 1 to Street 10 or downward from Street 10 to Street 1 along a specific avenue by taking 9 steps. This step is repeated 10 times to complete the zigzag pattern. 5. Changing avenues at the top Avenue 10. After each upward movement, the robot changes avenues at the top Street 10, turning right, moving forward 1 step to the next avenue, and turning right again to face downward. This process is repeated 5 times. For changing avenues at the bottom Avenue 1, when the robot reaches Street 1 at the bottom, it changes avenues by turning left, moving forward to the next avenue, and turning left again to face northward. This step is repeated 4 times to complete the zigzag pattern. Now, let us merge Move Along Avenue, changing avenues at the top, Move Along Avenue, and changing avenues at the bottom into one complete zigzag move. This step is repeated 5 times to complete the entire zigzag pattern. Each cycle includes the robot moving up, changing avenues at the top, moving down, and changing avenues at the bottom, ensuring a continuous zigzag motion across the grid. We need to modify our changing avenues at the bottom step to ensure that the robot doesn't smash into the wall. Since we are repeating the zigzag move 5 times, but there are only 4 changing avenues at the bottom, we must check if the left side of the robot is clear before performing the changing avenues at the bottom step. The robot should only change avenues at the bottom if the left side is clear, ensuring it can safely move to the next avenue without colliding with any obstacles. Now that we have a clear path laid out, let's walk through the algorithm step by step. First, we'll start by turning the robot to the left so it's facing the correct direction. Then, we'll set up a loop to repeat these steps 5 times, which will move the robot across each column of the grid. Here's how each loop will work. The robot will move forward along its current avenue, taking 9 steps to reach the end of the street. When the robot reaches the end of the avenue at street 10, it'll change avenues by turning right, moving forward 1 step, and turning right again. This will position it to move across the next avenue in the opposite direction. It will again move forward 9 steps along the new street. When it reaches the bottom street at street 1, it'll change avenues again if the left side of the robot is clear. This time, it will turn left, move forward 1 step, and turn left again to continue its path. Following these steps, our robot will complete the zigzag pattern, covering every cell on the grid from start to finish. Now that we've designed our algorithm, it's time to implement it and bring our zigzag robot to life. First, we import the necessary module and create the robot world using create_world. We also initialize our robot, Hubo, and set its pause time to 0.1 seconds, so the movements are visible, and its trace color to blue for better visualization. Next, we define a function move_along_avenue that moves the robot 9 steps along the current row, which represents moving across the avenue. We then create a helper function, turn_right, which turns the robot right by turning it left 3 times since the robot can only turn left by default. Next, we define a function change_avenue_at_top to handle the avenue changes at the top. The robot turns right, moves 1 step, and turns right again to face south. Next, we define a function change_avenue_at_bottom to handle the avenue changes at the bottom of the grid. Before changing direction, we check if the left side is clear, and if it is, the robot will reposition itself by turning left, moving forward, and turning left again. The zigzag_move function combines all these steps, moving along the avenue, changing the avenue at the top, moving down, and changing the avenue at the bottom. Finally, we start by turning the robot to the left to begin the pattern, and then we use a loop to repeat the zigzag move 5 times, covering the entire grid. With all of this in place, the robot will follow the zigzag path, ensuring it covers every cell from the top left to the bottom left corner. Alright, that's a wrap for today. I hope you found this video helpful and got some new insights. If you enjoyed it, don't forget to give it a thumbs up and hit that subscribe button so you won't miss out on future content. And hey, I'd love to hear from you in the comments below. Let me know what topics you'd like to see next or any questions you have.